Dear students, we take another example. Solution. Given series is 1 square into 1 plus 2 square into 3, 3 square into 5 plus and so on. Here, nth term of 1 square, 2 square, 3 square, is simply n square, because 1 square, 2 square, 3 square. Our T1 is 1 square, T2 is 2 square, T3 is 3 square, then Tn is n square. Similarly, nth term of 1, 3, 5 is a plus n minus 1 times d. We have a is 1 plus n minus 1 times d. D means common difference. The 3 minus 1, 2, 5 minus 3, 2. So d is 2. Or this is 1 plus 2n minus 2, the 2n minus 1. 1 minus 2 minus 1. Therefore, nth term of given series is Tn, and this is n square times 2n minus 1. 2n minus 1, and this is 2n cube minus n square. If we put n is equal to 1, then it gives 2 into 1 minus 1. 2 minus 1, 1. Our T1 is 1. Similarly, if we put n is equal to 2, then 2 into 2 cube, 16 minus 2 square, 4. The 16 minus 4, 12. Here, our T2 is 2 square into 3, 12. So our Tn is 100% correct. Okay, let Sn be the sum of first to n terms. Let Sn be the sum of first n terms. Then Sn is equal to sigma Tn, summation Tn. This is sigma. Our Tn is 2n cube minus n square. This is the 2 times of summation n cube minus summation n square. Now it becomes 2. Here n run from 1 to n. Sum of cubes of first n natural number. We have formula n square times n plus 1 whole square divided by 4 minus, here again n run from 1 to n. Sum of squares of first n natural number. n plus 1, 2n plus 1 divided by 6. Here 2 cancel, and n times n plus 1 divided by 2 is common. n plus 1 divided by 2 is common. Then remaining n plus 1 minus 2n plus 1 divided by 3, or it becomes n plus 1 divided by 2. Here taking LCM 3, the 3 times 3n square plus 3n minus 2n minus 1 and continue. N times n plus 1 divided by 2. Here 3n square plus 3n minus 2n, n minus 1 divided by 3, and this is n times n plus 1, 3n square plus n minus 1 divided by 6, which is the required answer. We take another example. Sum to n terms the series 1 square into 2 plus 2 square into 3 plus 3 square into 4 plus dot. Its solution here. The given series is 1 square into 2 plus 2 square into 3 plus 3 square into 4 plus dot. Here nth term of 1 square, 2 square, 3 square, dot is just n square. In alternative way, a plus n minus 1 times d whole square, like a 1 plus n minus 1 times d, the 2 minus 1, 1, 3 minus 2, 1 whole square, because 1 square, 2 square, 3 square whole square छ, स्क्वायर युज गरे, क्यूब थियो, क्यूब युज गर्छु, यसबाट कन्टिन्यू n square आइदिहाल्छ. Similarly, nth term of 2, 3, 4, this 2, 3, 4 is a plus n minus 1 times d, a plus n minus 1 times d. This is, here our a is 2, the 2 plus n minus 1 times d, d is again common difference is 1. So this is 2 plus n minus 1 and this is n plus 1. Therefore, nth term of given series, nth term of given series is Tn, which is equal to n square times n plus 1, n square times n plus 1, and this is n cube plus n square. If we put n is equal to 1, then 1 cube plus 1 square, which is 2. Here our T1 is 1 square into 2, 2. Similarly, if we put n is equal to 2, the 2 cube, which is 8, plus 2 square, which is 4, and sum is 12. And here our T2 is again 2 square into 3, 12. So our Tn is 100% correct. Now let Sn be the sum of first n terms. Let Sn be the sum of first n terms. then Sn is equal to summation Tn, and this is summation. Our Tn is n cube plus n square. The summation n cube plus summation n square. We have formula for sum of cubes of first n natural numbers, which is n square times n plus 1 whole square divided by 4. Similarly, sum of squares of first n natural numbers, which is n times n plus 1 into 2n plus 1 divided by 6. Here n times n plus 1 divided by 2 is common, then remaining n times n plus 1 divided by 2 plus here 2n plus 1 divided by 3 and this is n times n plus 1 divided by 2. Taking LCM, the 2 into 3 6 and 3 times the 3n square plus 3n plus 4n plus 2 and this is n times n plus 1 into 3n square plus 7n plus 2 divided by 12. And here continue. This is n times n plus 1. Here 3 into 2 6 and here is plus and here is 7. So we need to find two numbers whose product is 6 and sum is 7. So 7n can be written as here 3n square plus the 7n can be written as 6n plus n plus 2 divided by 12. And this is n plus 1. Here 3n is common. N plus 2 plus 1 n plus 2 divided by 12. And this is n times n plus 1 n plus 2 3n plus 1 divided by 12, which is the required answer. Dear students, now we are going to some ideas about arithmetico-geometric series. First of all, what is arithmetico-geometric series? Let A1 plus A2 plus A3 plus ... be any AP, that is any arithmetic sequence or arithmetic progression, and x plus x square plus x cube plus ... be any GP. Then the new series A1 times x plus A2 times x square plus A3 times x cube plus ... is called arithmetico-geometric series, that is AG series. तो के गरें एउटा एपी लिएको छु a1 plus a2 plus a3 अर्को मैले जीपी लिए x plus x square plus x cube र त्यो दुईटालाई corresponding multiply the first term लाई first ले second लाई second ले third लाई third ले multiply गरेर जुन न्यू सिरिज मैले पाउँछु त्यसलाई बोलिन्छ एजी सिरिज सो डिभाइड गर्दा पनि हुन्छ नाउ we take one example sum to infinity 1 plus 3x plus 5x square plus 7x cube plus dot dot to infinity. Solution. Given series is 1 plus 3x plus 5x square plus 7x cube plus dot 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 to infinity. We observe that given series is arithmetico-geometric series, that is AG series. Because if we take like 1, 3, 5, 7, then 1, 3, 5, 7 which are in AP. This is AP. Similarly, again we take 1, x, x square, x cube, dot dot dot. Then it becomes GP, which are in GP because T2 by T1, T3 by T2, T4 by T3. All ratios are same. This is GP. So, given series is arithmetico-geometric, that is AG series. Now, let S infinity be the sum to infinity. Let S infinity be the sum to infinity of given series. So, let S infinity is equal to 1 plus 3x plus 5x square plus 5x cube plus dot 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 to infinity, which is equation I. Now, multiplying both sides of I by x, that is common ratio of GP. के गर्ने अघिनाको मैले GP को कमन रेशियो निकाले थिए त्यसले GP लाई मल्टिप्लाई गर्ने यानी कि यो इक्वेसनलाई मल्टिप्लाई गर्ने त यो भन्छ x टाइम्स s इन्फिनिटी यसलाई मल्टिप्लाई गरे यहाँ लेख्छु x यसलाई गर्छु यहाँ लेख्छु सिमिलरली यसलाई मल्टिप्लाई यहाँ लेखे 5x क्यूब सिमिलरली infinity equation II. Now, the equation I minus II, subtracting II from I, we get I minus II, we get S infinity minus x times S infinity, which is equal to 1 plus 3x minus x, 2x, the 5x square minus 3x square, 2x square, the 7x square minus 5x cube, 7x cube minus 5x cube, 2x cube plus dot 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 to infinity. Or here S infinity is common, 1 minus x is equal to 1. Here 2x is common, 2x is common, then 1 plus x square plus dot 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 to infinity, and this is 1 plus 2x. This is an infinite GS. And we have formula. Formula is A times 1 minus r, 1 minus r, and this is 1 plus 2x into our A is 1 minus r, r is t2 by t1 x. Similarly, it becomes the 2x upon 1 minus x, taking LCM, then we get 1 minus x plus 2x divided by 1 minus x, and this is 1 plus x upon 1 minus x. Here s infinity times 1 minus x is equal to 1 plus x upon 1 minus x. So therefore, dividing both sides by 1 minus x, we get s infinity is equal to 1 plus x upon 1 minus x whole square, which is the required answer. Dear students, we take another example. Sum to n terms of the series 1 plus 2 by 2 plus 3 by 2 square plus 4 by 2 cube plus dot dot dot. Its solution. Given series is 1 plus 2 by 2, 3 by 2 square, 4 by 2 cube plus dot dot dot. Here, if we take 1, 2, 3, 4 and so on, then we get one series which is AP. Similarly, in denominator part only, the 1, if we take 1, the 2, the 2 square, the 2 cube, which are in GP. So given series is arithmetico-geometric series, which is AG series. Which is AG series. So it's Tn, the general term, nth term Tn, A plus n minus 1 times D divided by A into R square. Here in numerator part 1, 2, 3, 4 which are in AP, so we use Tn is equal to A plus n minus 1 times D. Similarly, in denominator part 1, here 1, 2, 2 square, 2 cube which are in GP. So we use Tn is A times R square. Okay, we take another example. Sum to n terms of the series 1 plus 2 upon 2 plus 3 upon 2 square plus 4 upon 2 cube plus dot dot dot. Given series is 1 plus 2 by 2, 3 by 2 square plus 4 by 2 cube plus dot dot dot. Here clearly, if we take only numerator part like 1, 2, 3, 4, which are in AP, 1, 2, 3, 4. Similarly, in denominator part, if we take 1, because 1 is 1 upon 1, 1, 2, 2 square, 2 cube, which are in GP. So, given series is arithmetico-geometric series, that is AG series, which is AG series. For these types of question, sum to n terms, first of all, we find its Tn, that is general term. Tn, so its Tn, general term is a plus n minus 1 times d upon a into r to the power n minus 1. Because here only numerator part only, we take 1, 2, 3, 4 which are in AP, so we use Tn is a plus n minus 1 times d. And clearly here in denominator part only 1, 2, 2 square, 2 cube, which are in GP. So we use Tn is a into r to the power n minus 1. And this is a. Our a is 1 plus n minus 1 into d. 2 minus 1, 3 minus 2, 4 minus 3, 1. Divide by a. We have a is 1 upon 1 is again 1. So a is, capital A is 1 r. T2 by T1. In GP, 2 upon 1 or 2 square upon 2, just 2 to the power n minus 1. And this is 1 plus n minus 1 divided by 2 to the power n minus 1. And this is just n upon 2 to the power n minus 1. If we put n is equal to 1, then 1 upon 2 to the power 1 minus 1, which is again 1. The 1 upon 1, 1. Our T1 is 1. Similarly, if we put n is equal to 2, and it becomes 2 upon 2 to the power 2 minus 1. The 2 by 2. T2 is 2 by 2. Similarly, if we put n is equal to 3 here, then our T3, 3 upon 2 to the power 3 minus 2. 2 to the power 2, and get 2 is square. Here, our T3 is 3 upon 2 square. So, our Tn is 100% correct. So, let Sn be the sum of first n terms. So, Sn is equal to 1 plus 2 by 2 plus 3 by 2 square plus 4 by 2 cube plus dot 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 n minus 1 upon 2 to the power n minus 2 plus n upon 2 to the power n minus 1. If we replace n is n minus 1, if we replace n is n minus 1, like n minus 1 n 2 to the power, here again n minus 1 minus 1. This is n minus 1 and 2 to the power n minus 2. We get previous term. And we have common ratio of GP is 2. So, multiplying both sides of equation 1 by 2, that is 1 upon 2 and here 1 upon 2 plus 2 square plus 3 2 cube plus dot 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 plus multiplying n minus 1 upon 2 to the power n minus 2 by 1 upon 2 becomes n minus 1 upon 2 to the power n minus 1 plus n 2 to the power n. Question I. त के गरे हाम्रो जीपी अहिले तल छ अघि नै मल्टिप्लाई गरे अहिले पनि जीपी लाई मल्टिप्लाई नै गरे हो तर देखिँदा डिवाइड गरेको जस्तो देखियो यसलाई गर्छु यहाँ लेख्छु यसको मुनि सिमिलरली यसलाई मल्टिप्लाई गरी 1 upon 2 ले यहाँ लेखे यसलाई गरे यहाँ लेखे र यो टर्मलाई गर्छु यसको मुनि जान्छ र एक स्टेप पछाडी जान्छ हामीले अर्थमेटिक सिरिजमा पनि यो कुरा भनिसकेका छौं नाउ I minus II we get Sn minus 1 upon 2 Sn 1 plus 2 minus 1 1 by 2 3 minus 2 2 square 4 minus 3 1 upon 2 cube plus n minus 1 and n cancel 1 upon 2 to the power n minus 1 here minus n upon 2 to the power n or here Sn is common 1 minus 1 upon 2 1 plus 1 upon 2 1 upon 2 square 1 upon 2 cube dot 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 2 n terms minus n upon 2 to the power n here 2 n terms because sum of its first n terms किनकि हामीले 2 n terms सम्म काम गरेका छौं अर्थमेटिक सिरिजमा यो बताए थिए मैले एउटा एक्स्ट्रा टर्म आउँछ त्यसलाई छोडेर अगाडि देखि काउन्ट गर्दा n terms here 1 plus 1 upon 2 plus 1 upon 2 square plus 1 upon 2 cube plus 2 n terms which are in GP so Sn 1 minus 1 upon 2 just 1 upon 2 1 upon 2 and here formula A is 1 times 1 minus R is T2 by T1 so 1 upon 2 upon 1 1 upon 2 to the power 2 n terms so we use here n upon 1 minus 1 upon 2 and here minus n upon 2 to the power n continue here 1 upon 2 Sn is equal to 1 upon 2 1 minus 1 upon 2 to the power n divided by 1 upon 2 minus n upon 2 to the power n or this is 1 upon 2 Sn the 2 times of 1 minus 1 upon 2 to the power n minus n upon 2 to the power n multiplying both sides by 2 or Sn is equal to 2 into 2 cancel the 4 1 minus 1 upon 2 to the power n minus 2n upon 2 to the power n. This is 4 minus 4 upon 2 to the power n minus 2n upon 2 to the power n, and it becomes 4 minus 4 is 2 square, then this is 1 upon 2 to the power n minus 2 minus here n upon by law of indices 2 to the power n minus 1, which is the required answer. Now we take another example, sum to n terms of the series. Solution is, given series is 1 upon 3 plus 4 upon 3 square plus 7 upon 3 cube plus 10 upon 3 to the power 4 plus dot dot dot. Clearly 1, 4, 7, 10. If we take numerator part only 1, 4, 7, 10, which are in AP. Similarly in denominator 3, 3 square, 3 cube, 3 to the power 4, which are in GP. So given series is arithmetico-geometric series, which is AG series. AG series. First we find its Tn, because we need to find sum of first n terms. So its Tn is equal to a plus n minus 1 times d upon a into r to the power n minus 1. किन माथि हाम्रो AP छ, AP को Tn निकाल्ने फर्मुला र तल हाम्रो डिनोमिनेटरमा GP छ, GP को Tn निकाल्ने फर्मुला. So it becomes 1 because a is 1, n minus 1, and d the 4 minus 1, which is 3, divide by a, I have first term of GP, which is 3, r the 3 square by 3, t2 by t1, the common ratio is again 3, n minus 1, and this is 3n, the 1 minus 3 minus 2, divided by law of indices 3 to the power 1 into 3 to the power n minus 1, 3 to the power 1 plus n minus 1, 1 and minus 1 cancel, just 3 to the power n. If we put n is equal to 1, then it gives 1 upon 3. Here our T1 is 1 upon 3. Similarly, if we put n is equal to 2, it gives 3 into 2 minus 2, which is 4 upon 3 square. Our T2 is 4 upon 3 square. So our Tn is 100% correct. Now let Sn be the sum of first n terms. Then Sn is equal to 1 upon 3 plus 4 upon 3 square plus 7 upon 3 cube plus 10 upon 3 to the power 4 plus dot dot dot. Your previous term 3n minus 5 upon 3 to the power n minus 1, 3n minus 2 upon 3 to the power n. In last term, if we put n is n minus 1, just n is replaced by n minus 1, then we get previous term. Now multiplying both sides of I by 1 upon 3, then we get 1 upon 3 Sn, so 1 upon 3 into 1 upon 3, 1 upon 3 square. Similarly 4 upon 3 square into 1 upon 3, 4 upon 3 cube. Similarly, 7 upon 3 cube into 1 upon 3, which is 7 upon 3 to the power 4, plus the 10 upon 3 to the power 4 into 1 upon 3, 10 upon 3 to the power 5. 3 to the power 5 plus dot dot dot. Here 3n minus 5 upon 3 to the power n minus 1 into 1 upon 3. 3n minus 5 upon 3 to the power n minus 1 into 3 to the power 1. Minus 1, 1 cancel, just 3 to the power n. Plus last one, 3n minus 2 upon 3 to the power n into 3 to the power 1, which is n plus 1. Equation II. Now, I minus II. We get here 1 minus 1 upon 3. 1 minus 1 upon 3, which is 2 upon 3. Here 1 upon 3, 4 minus 1, 3 upon 3 square, 7 minus 4, 3 upon 3 cube, 10 minus 7, 3 upon 3 to the power 4, dot dot dot, plus the 3n minus 2 minus 3n minus 5. 3n and the minus 3n cancel. The minus 2 minus minus plus 5, which is 3 upon 3 to the power n. And here minus 3n minus 2 upon 3 to the power n plus 1. Or this is 2 upon 3 Sn 1 upon 3 plus 3 upon 3 square, 3 upon 3 cube, and 3 upon 3 to the power 4 plus dot 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 2 n terms. And here minus 3n minus 2 upon 3 n plus 1. Or this is, again continue, 1 upon 3 plus 1 upon 3 plus 1 upon 3 square, 1 upon 3 cube. Here 3 upon 3 square, 3 cancel, 1 upon 3 remaining. Similarly 3 and 3 cancel, 1 upon 3 square, 3 and 3 cancel, 1 upon 3 cube, plus dot 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 2 n terms. Minus 3n minus 2 upon 3 to the power 1 plus n, 3 to the power n plus 1. Here T2 by T1, 1, T2 by T2, sorry, T3 by T2, 1 upon 3, T4 by T3, 1 upon 3. यदि यो एउटा नहुने हो भने यो कम्प्लिटली जीपी मा जान्छ. सो यसलाई हामी छोड्छौं. So this is 1 upon 3 plus 1 upon 3 plus 1 upon 3 square, 1 upon 3 cube plus dot dot 2 n minus 1 terms, minus 3n minus 2 upon 3 to the power n plus 1. यो कुरामा अलिकति स्टुडेन्टलाई क्लियर गराउँ. मैले अगाडि धेरै पटक देखाइसके. यहाँदेखि एउटा टर्म एक्स्ट्रा आउँछ. त हामी सम टु n टर्म्स निकालिरहेछौं. त 1 upon 3 from T1 to our last term, we get one additional term, Tn plus 1. This is Tn plus 1. This is Tn. यसलाई छोडिसकेपछि यो n टर्म्स अलवेज यो नेगेटिभ पार्टलाई छोडिसकेपछि अरु n टर्म्स यसमा फेरि मैले एउटा 1/3 अगाडि छोडे सो हियर n-1 यदि दुईवटा छोड्थे भने n-2 नाउ कन्टिन्यू 2/3 Sn is equal to 1/3 plus here 1/3 plus 1/3 square plus 1/3 cube plus 2 n-1 terms which is GS with first term 1/3 and common ratio is again 1/3. So we have formula A that is 1/3 1 minus R the T2 by T1 which is 1/3 whole to the power here n-1 n-1 upon 1 minus 1/3 1 minus R minus 3n minus 2 upon 3 to the power n plus 1 because sum A into 1 minus R to the power n upon 1 minus R in GS when R is less than 1. R is less than 1. तो मेरो n टर्म्स थियो मैले n राख्थे n-1 छ n-1 राखे n-2 थियो n-2 राख्थे धेरै जस्तो स्टुडेन्टले यही गल्ती गर्नुहुन्छ n-1 राख्ने कि n राख्ने रटेर पनि हुँदैन सो यहाँ हेर्नु पर्यो n-1 किनकि एउटा हामीले छोडेका छौं सो दिस इज 1/3 upon 1 minus 1/3 2/3 1 minus 1/3 whole to the power n-1 minus 3n minus 2 upon 3 to the power n plus 1. Here 3 cancel 1/3 plus 1/2 into 1 1/2 minus 1/2 into 3 to the power n-1 minus 3n minus 2 upon 3 to the power n plus 1. And here LCM of 3 and 2 is 6. The 2 into 1 2 3 into 1 3 minus here again LCM of 2 into 3 to the power n minus 1 and 3 to the power n plus 1 the 2 and here 3 to the power n minus 1 and 3 to the power n plus 1 3 to the power n plus 1 is LCM here 3 to the power n plus 1 and 2 is cancel and 3 to the power n plus 1 minus n minus 1 and n cancel 1 minus minus 1 1 plus 2 3 to the power 2 into 1 3 to the power 2 plus दुईटैको माइनस अगाडि आइसक्यो सो यो प्लस त कन्टिन्यू 1/3 plus 1/3 upon 1 minus 1/3 which is 2/3 here 3 cancel 1 minus 1/3 whole to the power n minus 1 minus 3n minus 2 upon 3 to the power n plus 1 this is 1/3 plus 1/2 into 1 1/2 minus 1/2 into 3 to the power n minus 1 minus 3n minus 2 upon 3 to the power n plus 1. Taking LCM of first two, we have 3 into 2, 6, 3 into 1, 2 into 1, 2 plus 3 into 1, 3 minus again taking LCM from last two here 2 into LCM of 3 to the power n minus 1 and 3 to the power n plus 1. And LCM is 3 to the power n plus 1. यहाँ के भयो 3 को पावर n minus 1 र 3 को पावर n plus 1 मा LCM ले n त हाम्रो पोजिटिभ हुन्छ त डेफिनेटली 3 to the power n minus 1 भन्दा 3 to the power n plus 1 बिगर हुनु पर्यो, ठुलो हुनु पर्यो। त ठुलो पार्टलाई LCM लिए। नाउ 2 to cancel, the 3 to the power n minus 1, 3 to the power n plus 1. यसले यसलाई डिवाइड गर्दा 3 to the power n plus 1 upon 3 to the power n minus 1. साइडमा देखाएँ 3 to the power n plus 1 upon 3 to the power n minus 1. This is 3 to the power n plus 1 minus n plus 1. And cancel, this is 3 to the power 2. That is 9. So 9 into 1, 9. The minus minus यहाँ कमन भइसकेको छ। सो यसमा पनि स्टुडेन्टले धेरै रङ गर्न सक्छ, यो साइन चेन्ज हुन्छ। प्लस 3 to the power n plus 1, 3 to the power n plus 1 cancel, 2 ले जस्ट मल्टिप्लाई गरौँ, 2 ले मल्टिप्लाई 6n minus 4, which is 5 upon 6 minus 6n plus 5, because 9 minus 4 is 5, upon 2 into 3 to the power n plus 1. Now continue. The 2 upon 3 Sn is equal to 5 upon 6 minus 6n plus 5 upon 2 into 3 to the power n plus 1. Here coefficient of Sn is 2 upon 3. So multiplying both sides by its reciprocal 3 by 2. Here 2 upon 3 into 3 upon 2 Sn is equal to 5 upon 6 minus 6n plus 5 upon 2 into 3 to the power n plus 1 into 3 upon 2. Yeah, 3 cancel, 2 cancel. Therefore, Sn, the 5 upon 6 into 3 upon 2 minus 6n plus 5 upon 2 into 3 to the power n plus 1 into 3 by 2. Here 3 2 times, so this is 5 upon 4 minus 6n plus 5 divided by 2 into 2 4 into 3 to the power n plus 1, here 3 to the power 1 by law of indices, 3 to the power n plus 1 minus 1, which is 3 to the power n, which is the required answer. Okay, we take another example. Sum to n terms of the series 1 upon 5 plus 5 upon 5 square plus 9 upon 5 cube plus 13 upon 5 to the power 4 plus dot dot dot. So its solution is given series is 1 upon 5 plus 5 upon 5 square, 9 upon 5 cube, 13 upon 5 to the power 4 plus dot dot dot. If we take the numerator part only, 1, 5, 9, 13, which are in AP. Similarly, in denominator part, 5, 5 square, 5 cube, 5 to the power 4, which are in GP. So, given series is AG series, which is AG series. So, first of all, we find its Tn. Its Tn, general term is A, we have A is 1 plus n minus 1 times D. Our D is the 5 minus 1, 4, divided by A. We have A is 5 and D, sorry, R, A, R. R is 5 square by 5, just 5 to the power n minus 1. A plus n minus 1 times D upon A into R to the power n minus 1. And this is 1 plus 4n minus 4 divided by law of indices here 5 to the power 1 and 5 to the power 1 plus n minus 1. 1 minus 1 cancel, 5 to the power n only. This is 4n minus 3 upon 5 to the power n. If we put n is equal to 1, then it gives 4 into 1 minus 3, just 1, 5 to the power 1, which is 1 upon 5. Our t1 is 1 upon 5. Similarly, if we put n is equal to 2, 4 into 2, 8 minus 3, which is 5 upon 5 square. Our t2 is 5 upon 5 square. So our tn is 100% correct. And here is, if we put n is equal to n minus 1, that is n is replaced by n minus 1, then we get previous term. Previous term is 4n minus 1 minus 3 upon 5 to the power n minus 1. त्यो लास्ट टर्म भन्दा अगाडि लेख्नलाई कतिपय स्टुडेन्टलाई प्रब्लम हुन्छ. अगाडि मैले भनिदिएको थिएँ, यहाँ देखाइरहेको छु र यो आउँछ 4n minus 4 minus 3 minus 7 divided by 5 to the power n minus 1. Now let Sn be the sum of first n terms. Then we have Sn is equal to 1 upon 5 plus 5 upon 5 square plus 9 upon 5 cube plus 13 upon 5 to the power 4 plus plus previous term plus general term is tn. अघि हामीले जुन निकालेको थियौं tn राखे, त्योभन्दा अगाडिको टर्म त्यो पनि निकालेर देखाएको थिएँ, त्यसलाई युज गरे. नभए सिधै 4n minus 1 4n minus 3 minus 4 गर्दा 4n minus 7 हुन्छ. Similarly, n is replaced by n minus 1, 5 to the power n minus 1. The next लेख्नु छ 4n minus 7 minus 4, 4n minus 11 upon 5 to the power n minus 2. त्यसरी राख्न सकिन्छ. Now, multiplying equation I by 1 upon 5, because our common ratio of GP is 5. 5 square upon 5. We get 1 upon 5 Sn is equal to 1 upon 5 into 1 upon 5. 1 upon 5 square. 5 upon 5 cube. यसलाई मल्टिप्लाई गरी यहाँ लेखी, यसलाई मल्टिप्लाई गरी यहाँ लेखी, यसलाई मल्टिप्लाई गर्छु फेरि यहाँ राख्छु. यसलाई गर्छु यता राख्छु. सरी, यहाँ मेरो 4 हुनुपर्ने, यहाँ 5 प्लस यसलाई मल्टिप्लाई गर्छु 4n minus 7 upon 5 to the power n minus 1 into 5 to the power 1. Minus 1, 1 cancel, just 5 to the power n plus last 4n minus 3 upon 5 to the power n into 5 to the power 1. The by law of indices 5 to the power n plus 1. Equation II. Now I minus II, we get I minus II, we get here 1 minus 1 upon 5. 4 upon 5 Sn, 1 upon 5, 5 minus 1, 4 upon 5 square, 9 minus 5, 4 upon 5 cube, plus 13 minus 9, 4 upon 5 to the power 4, plus here 4n minus 3 minus 4n minus 7. 4n minus 4n cancel, minus 3 plus 7, which is 4 upon 5 to the power n. तो यहाँ केही पनि छैन, so यो negative 4n -3 upon 5 to the power n plus 1 किनकि हामीले I minus I गरिरहेका छौं. So this is 1 upon 5 plus 4 upon 5 square, 4 upon 5 cube, 4 upon 5 to the power 4 plus 2 n terms minus 4n minus 3 upon 5 plus 5 to the power n plus 1. तो यो n terms कसरी हुन्छ अगाडिको क्लासमा हामीले डिस्कस गरिसकेका छौं. कसरी n वटा भयो, एउटा छोडेर अलवेज लास्टलाई छोडेर n वटा हुन्छ किनकि हामी सम टु n terms निकालिरहेका छौं. Here T2 by T1, T3 by T2 गर्दा यो कम्प्लिटली जीबी मा गएन किनकि यहाँ 4 छ 4 छ 4 छ. त योबाट स्टार्ट गरे भने यो अब जीबी बन्छ. त्यसकारण यहाँ पनि एउटालाई छोड्नु पर्यो अघिको जस्तै. So this is 1 upon 5. The 4 upon 5 square is common. 1 plus 1 upon 5, 1 upon 5 square plus 2. यहाँ एउटा छोडियो. So here n minus 1 terms minus 4n minus 3 upon 5 to the power n plus 1, which is 1 upon 5 plus 4 upon 25. यहाँ हामी फर्मुला लाउँछौं जीपी को. A is 1, A times 1 minus r to the power n whole upon 1 minus r, and our r T2 by T1 1 upon 5 to the power n minus 1. अघि पनि भने यसमा मिस्टेक हुन सक्छ. n टर्म्स छ, n राख्ने. यहाँ हाम्रो n minus 1 छ. सो यहाँ n minus 1 upon 1 minus 1 upon 5 minus 4n minus 3 upon 5 to the power n plus 1. 4 upon 5 Sn is equal to 1 upon 5 plus 4 upon 25, 1 minus 1 upon 5 whole to the power n minus 1 upon 1 minus 1 upon 5 minus 4n minus 3 upon 5 to the power n plus 1. This is 1 upon 5 plus the 4 upon 25 upon 1 minus 1 upon 5, which is 4 upon 5. 1 minus 1 upon 5 to the power n minus 1 minus 4n minus 3 upon 5 to the power n plus 1. Here 1 upon 5 plus 4 upon 25 into 5 upon 4. 1 minus 1 upon 5 to the power n minus 1 minus 4n minus 3 upon 5 to the power n plus 1. The 4 cancel, 5 ले 5 times. So you have 1 upon 5. Here 1 upon 5 into 1. 1 upon 5 minus 1 upon 5 into 5 to the power n minus 1. The 5 to the power n minus 1 plus 1. क्योंकि 5 को पावर है 1 छ. The 1 र minus 1 cancel, 5 to the power n minus 4n minus 3 upon 5 to the power n plus 1. Here 1 upon 5 plus 1 upon 5, 2 upon 5 minus the LCM of 5 to the power n and 5 to the power n plus 1 is 5 to the power n plus 1. Now dividing 5 to the power n plus 1 upon 5 to the power n, and n cancel, just 5 to the power 1, which is 5. 5 into 1, 5. Plus minus minus agadi छ. The 5 to the power n plus 1 divided by 5 to the power n plus 1, which is 1. 1 into 4n minus 3, just 4n minus 3. This is 2 upon 5 minus 4n plus 2. 5 minus 3, 2, divided by 5 to the power n plus 1. Now multiplying both sides by 5 upon 4, because coefficient of Sn is 4 upon 5 and its reciprocal is 5 upon 4. The 4 upon 5 into 5 upon 4 Sn is equal to 2 upon 5 into 5 upon 4 minus 4n plus 2 upon 5 to the power n plus 1 into 5 upon 4. Here 4 4 cancel, 5 5 cancel, therefore Sn is equal to, here 5 5 cancel and 2 times, this is 1 upon 2 minus, here 2 is common, the 2n plus 1 upon 5 to the power n plus 1 into 5 upon 4. This is 2 times, this is 1 upon 2 minus 2n plus 1 upon 5 to the power n plus 1, here 5 to the power 1. Talalem by law of indices 5 to the power n plus 1 minus 1, किनकि हाम्रो 5 को power 1 छ. This is 5 to the power n. र यो नै हाम्रो answer. Now we take another example, sum to n terms of the series. The solution is, given series is 3 into 2 plus 5 into 2 square plus 7 into 2 cube plus dot dot dot. Here 3, 5, 7, which are in AP. 3, 5, 7. Similarly, 2 square, 2 cube, which are in GP. अगाडिको मात्र लियो AP भयो, पछाडिको मात्र लियो GP भयो. So given series is AG series, which is AG series. So it's Tn. Tn of 3, 5, 7 and so on, which is A plus n minus 1 times t. 3 plus n minus 1 times d. The 5 minus 3, 2, 7 minus 5, 2, into the Tn of 2 square, 2 cube, which is A into r to the power n minus 1. Our A is 2 and r 2 square by 2. Our 2 cube by 2 square, which is again 2 n minus 1. तो अघि नै के थियो, डिवाइड गरेको थियो अघिको प्रब्लममा, माथि एपी थियो तल जीपी थियो, अहिले दुईटै सँगै छ, मल्टिप्लाई भएको छ, सो मल्टिप्लाई गरे. So this is 3 plus 2n minus 2, 2 to the power n. This is 2n plus 1, 2n plus 1 into 2 to the power n. If we replace n by n minus 1, then we get previous term. The previous term is 2 times of n minus 1 plus 1 into 2 to the power n minus 1. तो यो भन्दा अगाडिको टर्मको लागि n को ठाउँमा जस्ट n minus 1 राख्ने, यहाँ एकचोटी यहाँ एकचोटी. तो यो आयो 2n minus 2 plus 1 minus 1 into 2 to the power n minus 1. Let Sn be the sum of first n terms of given series. Then Sn is equal to 3 into 2, 5 into 2 square plus 7 into 2 cube plus dot dot dot, the previous term plus the Tn. Now multiplying both sides of I by common ratio of Gp, that is 2, and 2Sn is equal to 3 into 2 into 2, 3 into 2 square. यसलाई मल्टिप्लाई गरी यसको मुनि राखेँ. Similarly 5 into 2 cube. Similarly 7 into 2 to the power 4 plus dot dot dot. यसलाई मल्टिप्लाई गर्छु, यसको मुनि लेख्छु 2n minus 1 into 2 to the power n minus 1 into 2 to the power 1. Minus 1, 1 cancel, just 2 to the power n. Plus last यसलाई गर्छु 2n plus 1 into 2 to the power n plus 1. Equation II. Now I minus II. We get Sn minus 2Sn Sn minus 2Sn, which is minus Sn, minus Sn, 3 into 2, and this minus this, the 5 minus 3, 2 into 2 square, 7 minus 5, 2 into 2 cube. Similarly, the 2n plus 1 minus 2n minus 1, 1 minus minus 1, because 2n to minus 2n cancel. This is 2 into 2 to the power n plus, sorry, here minus is nothing. So 1 minus I minus II, we get minus 2n plus 1 to 2 to the power n plus 1. This is 6 plus 8 plus 60 plus dot 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 2 n terms minus 2n plus 1 into 2 to the power n plus 1. T2 by T1 is not equal to T3 by T2. यहाँ पनि हामीले 6 लाई छोड्नु पर्यो, त्यसपछि यो कम्प्लिटली जीपी मा जान्छ. 6 plus 8 plus 16 plus dot 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 2 n minus 1 terms minus 2n plus 1 into 2 to the power n plus 1. 2 to the power n plus 1. 6 plus sum of GS. We have formula A is 8, R to the power n. We have R is T2 by T1, 16 divided by 8, 2. 2 to the power here n minus 1. Minus 1 divided by R minus 1, 2 minus 1, minus 2n plus 1 into 2 to the power n plus 1. And this is 6 plus 8, it is 2 cube plus n minus 1 minus 8 into 1 minus 8 minus 2n plus 1 into 2 to the power n plus 1 upon 2 minus 1 is just 1. Now, minus Sn is equal to here 6 minus 8 minus 2 plus 2 to the power here n plus 2 minus 2n plus 1 into 2 to the power n plus 1. Here coefficient of Sn is minus 1, so multiplying both sides by minus 1, we get Sn, this is positive, minus 2 to the power n plus 2, this is नेगेटिभ, सो पोजिटिभ -1 ले मल्टिप्लाई गर्यो 2n + 1 × 2 to the power n + 1. This is 2 - 2 to the power n + 2 plus here 2n × 2 to the power n + 1 plus 2 to the power n + 1. 2 - 2 to the power n + 2, here 2 × 2 to the power n + 1. The n times 2 to the power n + 2 plus 2 to the power n + 1. The 2 here 2 to the power n into 2 to the power n + 2 minus 2 to the power n + 2 plus 2 to the power n + 1. This is 2 plus here 2 to the power n + 2 is common. Then this is 2 to the power n + 2 n - 1 plus 2 to the power n + 1, which is the required answer. Now we take another example. Sum to infinity a upon x plus b upon x square plus a upon x cube plus b upon x to the power 4 plus dot dot. So its solution s infinity is a upon x plus b upon x square plus a upon x cube plus b upon x to the power 4 plus dot dot dot. Now collecting a by x, a upon x cube, similarly a upon x to the power 5 and so on, we get a upon x plus a upon x cube plus a upon x to the power 5 plus dot 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 to infinity, plus now collecting b upon x square plus b upon x to the power 4 plus b upon x to the power 6 and so on, we have b upon x square plus b upon x to the power 4 b upon x to the power 6 plus dot 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 to infinity. Here a upon x is common, so it becomes 1 plus 1 upon x square plus 1 upon x to the power 4 plus dot 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 to infinity, plus here b upon x square is common, then it becomes 1 plus 1 upon x square plus 1 upon x to the power 4 plus dot dot to infinity. Here is again common, 1 plus 1 upon x square plus 1 upon x to the power 4 plus dot 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 to infinity is again common. Then we have a upon x plus b upon x square times 1 upon x square plus 1 upon x to the power 4 dot dot to infinity. Here LCM is x square and ax plus b. Here 1 plus 1 upon x square plus 1 upon x to the power 4 plus dot dot dot, which is infinite GS. And first term a is 1 and common ratio is 1 upon x square. Here given modulus of x is greater than 1, then common ratio r is 1 upon x square, because t2 by t1 gives the common ratio, and modulus of x is greater than 1, so 1 upon greater than 1 is always less than 1, so it has finite sum. So formula is a upon 1 minus r, and this is ax plus b upon x square into a is 1 upon 1 minus r, is t2 by t1, 1 upon x square, and it becomes ax plus b upon x square into 1 upon the 1 minus 1 upon x square, which is x square minus 1 upon x square cancel, The answer is ax plus b upon x square minus 1. We take another example, sum to infinity, 1 plus 3 upon 4 plus 7 upon 16 plus 15 upon 64 plus dot dot dot. And solution, as infinity is 1 plus 3 upon 4 plus 7 upon 16 plus 15 upon 64 plus dot 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 to infinity. This is neither AP nor GP because T2 minus T1 is not equal to T3 minus T2. Similarly, T2 upon T1 is not equal to T3 upon T2. So, this is 1 plus and 3 can be written as 4 minus 1 upon 4 plus here 7, 8 minus 1 divided by 16 plus 15 can be written as 16 minus 1 divided by 64 plus dot 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 to infinity. Denominator हेरेर 3 लाई 4 minus 1 गरे र 7 को ठाउँमा मैले यहाँ 16 माइनस त गर्न मिलेन, सो 8 minus 1 गर्छु र 15 लाई 16 minus 1 गर्छु ताकि म यसलाई कम्प्लिट जीपी मा लैजान सकूँ. 1 plus the 4 by 4 again 1 minus 1 upon 4 plus 8 by 16 which is 1 upon 2 minus 1 upon 16 plus 16 by 64 1 upon 4 minus 1 upon 64 plus dot 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 to infinity. Now taking positive part only, the 1 plus 1 upon 2 plus 1 upon 4 plus dot 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 to infinity. Now collecting the negative part, we have 1 upon 4, the minus 1 upon 4, minus is common, then 1 upon 4 plus the minus 1 upon 16, here minus is common, so only 1 upon 16 plus 1 upon 64 plus dot 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 to infinity. Here 1 upon 1 again 1, 1 upon 2 upon 1, 1 upon 2, 1 upon 4 upon 1 upon 2, 1 upon 2. So यसलाई छोड्ने भने यो जीपी बन्छ. सो मैले यहाँ पनि 1 लाई छोड्छु. अब सुरु गरी 1 plus 1 upon 2, 1 upon 4 plus dot 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 to infinity minus common लिदियौं 1 upon 4, 1 plus 1 upon 4 plus 1 upon 16 plus dot 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 to infinity. Now 1 plus the formula of infinite GP, sum of infinite GP the formula A is 1 upon 1 minus R is 1 upon 2 minus the 1 upon 4 A is again 1 upon 1 minus R is T2 by T1 gives 1 upon 4 upon 1 gives 1 upon 4. Okay, continue. S infinity is equal to 1 plus 1 upon 1 minus 1 upon 2 minus 1 upon 4 into 1 upon 1 minus 1 upon 4. So it becomes 1 plus 1 upon 1 minus 1 upon 2, 1 upon 2 minus 1 upon 4 into 1 upon 1 minus 1 upon 4, 3 upon 4. Here 4 cancel. 1 plus 1 upon 1 upon 2 is just 2 minus 1 upon 3. So 1 plus 2, 3 minus 1 upon 3 and 3 minus 1 upon 3, so 3 into 3, 9 minus 1 which is 8 upon 3 which is the required answer, but it does not work anytime. So we have alternative method. Okay, we have alternative method. Let S infinity is equal to 1 plus 3 upon 4 plus 7 upon 16 plus 15 upon 64 plus to infinity. In denominator part, we take 1, 4, 16, the 64 which are in GP. So common ratio of GP is 4. So multiplying both sides of equation I by 1 upon 4, we have 1 upon 4 as infinity. So 1 into 1 upon 4, 1 upon 4, 3 upon 4 into 1 upon 4, 3 upon 16, 7 upon 4 into 1 upon 4, 7 upon 64, the 15 upon 16 into 1 upon 4, just the I minus II, we get here 1 minus 1 upon 4, 1 minus 1 upon 4 as infinity. The 1 here 3 minus 1, 2, 2 by 4, 7 minus 3, 4 by 16, 15 minus 7, 8 by 64 plus to infinity. The 1 minus 1 upon 4, which is 3 upon 4 as infinity, 1 plus 1 upon 2, 1 upon 4, 1 upon 8 plus to infinity. Here 1 plus 1 upon 2 plus 1 upon 4 plus 1 upon 8 plus which is purely GP. With first term 1 and common ratio to T2 by T1, 1 upon 2 upon 1 gives 1 upon 2, then modulus of 1 upon 2 is again 1 upon 2, which is less than 1. So it has finite sum. So formula A 1 upon 1 minus R. R is T2 by T1, 1 upon 2. So this is 1 upon 2. This is just 2. Here coefficient of S infinity is 3 by 4. Now multiplying both sides by 4 upon 3, it's reciprocal. 3 upon 4 into 4 upon 3, just 1 S infinity, and right hand side becomes the 2 into 4 by 3, which is 8 by 3, which is the answer.